Okay, so I think we can slowly start welcoming people to our session. It's 2 p.m., so thank you everyone for tuning in. Perhaps we wait a few more minutes for more people to join, but before we officially start this breakout session, I want to welcome you to Expo Day number 2. As you well know, we are celebrating 5 years of Startup Autobahn and 10 amazing programs. For those of you who don't know me, I am Theodora. I'm part of the ventures team at Startup Autobahn, and my role is to scout and discover interesting startups for our corporate partners. And today, the session is run with DXC technology and our program 10 Startups. So, on page, first of all, Philip Vende. He's a senior consultant and innovation program lead at DXC Technology. Hi, Philip.
Hi, thanks. It's good to be here.
And then we have Marian Glazer, co-founder and CEO at Brighter AI. Hi there.
Hello, everyone. Good to be here as well.
And then we have Tobias. He's Vice President Sales and Business Development at Brighter AI. Nice to have you here, Tobias.
Thanks for having us. Hi.
Hi. So you have been working over the past few months to try to advance DeepTech AI to make image and video data in autonomous driving compliant with GDPR regulations and in general with data privacy regulations around the world. So we would be looking forward to learning more about what you've done over the past few months, where you are at now, and what maybe the future holds for you. And then I know you have a really exciting agenda prepared for today. You have a live demo. You're going to be talking about also other use cases beyond the automotive space and how your technology can transfer to different industries. So that's also very, very interesting. So I don't want to take maybe too much of this intro time. I would just let Philip maybe take the stage now and introduce us more to the project and to the work that you guys have been doing.
Okay, great. So yeah, generally for the session, feel free to post any questions you might have or comments in the chat. So we will observe the chat and try to answer every question you might have. Also, we will have a break every now and then to make maybe have a short discussion or so. So just to set the stage a little bit, we want to keep the session interactive. So if you want to contribute anything, feel free to do so. I might go ahead and start with talking a little bit about the program we went through in general. So program 10 and the collaboration with Brighter AI. We've been in touch with the company for quite some time now, and it's actually been really cool. It's been quite a good example of corporate startup collaboration, I think. So we started in the very beginning, just exploring joint opportunities and how like a certain startup technology fits into what DXC does and how we can support each other with our expertise. And slowly but steadily we were moving forward and progressing, and eventually we figured out that it makes a lot of sense to take the deep technology from Brighter AI and put it into our offering that is called robotic drive. We will talk about that in just a minute. So the idea is having that solution put into our larger scope of an offering, a platform actually, and then sell this to our joint clients. So just to set the scene a little bit, this collaboration has been extremely fruitful. It has been very exciting. We've met a lot of people in the meantime, and I can only recommend working with Brighter AI from my point of view. I just want to kick that out in the very beginning of our session. And I think now we can get started. So you already see the title, DeepTech AI for GDPR-Compliant Autonomous Driving Data at Scale. So that's quite a long title, but this is essentially what it is about, what we want to, oh, hang on, I have to, what we want to talk about today. So with the vehicles that we see on the road, and generally mobility being in a huge transformation right now, what is happening is that companies have this overarching goal of making cars drive autonomously. So how do you manage to do that? Because you right now, unfortunately, in most cars, you don't have that button you click on and say, now drive autonomously. But we have to develop it. And how do you do it? You install different sensors on a test car, and you drive around with it. And the car basically captures the environment around it, for example, in video data. And that is being collected and used to train algorithms that will in a later stage be implemented into the car and enable the autonomous driving functions. Now, I'm sure most of you probably know how this works and how this is going, but we have to understand that in order to do so, vast amount of data have to be collected and stored in huge data lakes in order to enable engineers to build these algorithms and these models. So cars driving around, collecting video data, extremely large files, so to say, and inserting them into computing clusters. So we basically wanted to describe the challenge that there's, first of all, a large amount of data, and then the second side, we have to take into consideration that the data that is being collected is just image video data of you and me, right? And it could be anyone, it could be a car driving around, it could be person standing on the side of the road, and that is essentially personal information that companies do need to protect. And especially today, I think all companies that collect these data, they decide to collect this data knowing that it's private data, they have a certain social responsibility towards every individual that they capture, that they have to somehow find a way to protect that privacy information that they have stored. And then there's certain regulations that come from the government, like GDPR, that are regulating this kind of turf. And in the end, there needs to be between the regulation and the company's social responsibility, they need to meet, and they need to find a way, technology-wise, but also process-wise, on how to basically ensure that data privacy is being held. So this is kind of concerning the challenge that the Brighter AI and us were looking into. And we wanted to give you just a quick overview of what the project looks like. DXC being an end-to-end IT systems integrator and a huge partner of many OEMs and tier one suppliers in the market that are developing driving functions and autonomous driving with our offering, Robotic Drive, and several other offerings we have in the autonomous driving space. We had some great capabilities, and obviously the platform itself that we could base our demo on or our POC on as kind of a starting point of what we were doing. And now I want to pass it over to Marian to give him a chance to describe who Brighter AI is and what they were contributing to our joint solution.
Thank you very much, Philip, and actually great introduction of the challenge, because that's exactly what we're looking at. We were founded about 4 years ago in the automotive industry to co-found it with Hella. And the industry is, as you said, facing this issue of more and more data being collected, but social responsibility, company reputation, and the more data effectively that is collected, the more sensitive it becomes for a company to properly protect it. And so we anonymize image and video data. We are market leader in new anonymization technology, specifically for AI. Very excited that you actually later on in the demo demonstrate what we jointly put up here in our cooperation. And it was also for you guys fantastic working with DXC, and actually the synergies to bring in a data protection solution into Robotic Drive, into a data pipeline that is then being used for automotive development, is, I think, a huge step towards orchestrating autonomous data for autonomous vehicles, collecting it for research and development, and in the end being able to accelerate in this space to move self-driving cars forward. So yeah, great pleasure working with you guys, and yeah, that's a bit for us, and handing over back to you.
Okay, great. Thanks, Marian. So I think I hope the idea got clear that we have this development platform in place, and we put Brighter AI on the platform to provide any user an even greater experience and more value in using that kind of platform. But I think it's going to be the easiest way to show you what this mission is: protect every identity on the road, in a little demo that we have prepared. And I'm actually going to hang on. We have this screen demo coming up. So I'm actually going to switch from the PowerPoint presentation to our web demo. I hope you can see the screen. And in this, we kind of want to show you how the flow could look like. And since we're a service company, we don't have a product developed, that is off shelf and fixed, but this is supposed to give you an impression of what a solution could look like that we implement in the environment of one of our clients that we're actually already planning as of right now. We have developed this kind of interface to show you, you would, for example, imagine you are an engineer supposed to develop driving functions. So you have ingested a certain amount of data from a test car, or you have received it from any cluster data you might had already, and you basically have just this folder structure with all this data, and you can now decide, depending on the use case, okay, we need this data for sending it over to someone else for labeling, or we want to do whatever. So you can select different pieces of data and decide, I want to anonymize those. So let's check out some of the examples. We just tried to put in some examples that may be representative for some of the use case scenarios you have. So for example, there's a car standing here, and it shows a license plate of I think it's a Ljubljana license plate. And this is already a personal information that might be relevant to be protected. On the other hand, we can look at actually a car driving around, filming video on the street, which would be an image and a video like that. And again, you can see license plates that need to be anonymized. Or we have actually some footage. Sorry, we have some footage from Tübingen in Germany that we want to show you, where you can see both license plates, and that's just someone walking around in the city. But you can see license plates, all kinds of license plates that need to be protected, but also there are people walking around, and you can see their faces, so they need to be anonymized to be protected in one way or the other. So the general idea is that you select the files that you might want to take. For example, let's take this video. Let's also take the picture of this this car, and maybe let's even go ahead and take kind of an edge case, people that have masks on, because the algorithm does work with edge cases like that also. So let's select these three, and then we would go ahead and continue the process. And now the cool thing about Brighter AI is that you basically have two different options, depending again on the use case that you have, on how you want to proceed with the anonymization, because there are different ways of how you can do it. And Marian already said that Brighter AI is basically an expert in deep natural anonymization, which is a special way of anonymizing pictures. And you can see this here already. And Marian is just, I'm going to pass it over to Marian in just a second so he can say a few words about that. On the other hand, for example, if you have a scenario where you just have a bulk amount of data that you want to anonymize, you can go ahead and just say it's enough if I blur the faces, which is the more pragmatic way, the easier way to anonymize. But you will lose a certain functionality that you might need later that I'd like to pass it on to Marian to maybe share a little bit about how this works and what's cool about it.
Yes, so actually a good example and good start with the right image, because there, as you say, you lose certain information. For example, where did the worker look at, in which direction? Actually, age and gender is also missing and mimics entirely. So any kind of behavioral prediction, transferring it in other use cases, you wouldn't be able to do anymore. On the left side, where you see the deep natural anonymization in the workflow to start to be processed, you have on the left the original image, and on the right you have the anonymized. And we actually modify and replace the original image in a way that it's completely afterwards being usable for AI training purposes, as well as a very detailed labeling. However, the facial points, they're differed and altered in a way that you cannot run any facial recognition on them anymore, giving them a basic data protection to not being able to find identities in the data set anymore. And on the other hand, they distinctly become different to bring an uncertainty in that you cannot recognize the person anymore. And especially for big data sets, what we're looking at in the automotive space, those components are crucial, that the data is sufficiently protected that you cannot find basically individual identities through crawling the data set or going through the data set, and at the same time keep all those attributes and being able to process them sufficiently.
Yeah, I think that summarizes it actually really great, and I think we can all agree on that. If you go ahead and manually look at a picture like that, you will probably recognize this person. If he's your friend, for example, you will probably still be able to tell, like, oh, okay, this is Tom. I clearly recognize Tom. But that's not the use case we're talking about. It's exactly what Marian said, that a recognition engine or a model would just not be able to tell that this is the same person, right? It would definitely say it's a different person, and that way you can comply with GDPR. And quite frankly speaking, also considering that you have a certain responsibility. We're talking about huge data sets where there's the probability that someone actually goes into these data sets and recognizes a person and can manually tell, like, oh, this is this person. That's just not something that would happen. And therefore, that is definitely compliant with GDPR. And the great thing is, as Marian has indicated, you can still use it to train models with, which you can't do, for example, if you blur the face, because if you have an image like that, you will just not be able to see the direction this person was looking at, or the age, or anything that Marian just said. So let's check out the blurring first. So if we anonymize the data that we have now selected to anonymize, we go ahead and do that, and we can, for example, again look at the picture of the. Oh, hang on. Now I already showed you the anonymized version, but you can clearly see every picture was every face was detected by the algorithm, even the Mona Lisa in the background, and it was blurred out. And if we look again at the original picture, this was how it was looking like. So obviously the blurring is anonymizing everyone, and this is a well-known feature, I think, or a well-known thing that you can do. Oh, sorry, now I started over completely. But now the next thing we want to do, which I think will be more interesting for you, is actually the deep natural anonymization. So let's let that anonymize again. And then we can see that, for example, let's have a look again at the BMW. You see there's the Ljubljana, Slovenia license plate. And now look at the anonymized picture. And the cool thing is, this is the deep natural anonymization. So it's not blurred out, but you still see a license plate, but now it's a completely different license plate. And it could really be anything. So either you tell the algorithm, okay, please replace it with this kind of license plate, or for example, you want to put a Stuttgart license plate, or a Chinese license plate, or perhaps a company logo, or anything you would want to do. You can tell the algorithm to do so, and it will just overlay the old license plate with the new one. And let's look again at now the picture of the people having the masks on. And you can clearly see even the Mona Lisa was changed, especially if you look at the eyebrows, if you look around the eyes, and some of the facial markers and these feature points the face has. You can see everyone was, even though they had the mask on, they were recognized, and the faces were overlaid with an artificial version of a new face. And now if we want to look at the video, for example, we can do that also. And I'll go into full screen so you might be able to see that better. The license plates you can see now, for example, this has a Göttingen license plate. Earlier it has a Tübingen license plate. We can look at the original video just in a second. And you also see it's kind of hard to tell. So let me click on stop right here. You can see that even in a video, not in only a a certain frame, the faces of these people are being artificially adapted, and that would basically already state that you can't recognize them with a model anymore, or you can't. You basically can ensure the privacy of those people when the algorithm detects them and changes that. And again, here you could see the license plate being changed. So I think that's quite a good example of how the solution works, and that it actually works out really well. And if we have a look at the original just one more time, again, I will go to full screen so you can see it better. You can see this one had a Böblingen license plate, and this car has a Tübingen license plate. So specifically for the license plates, I think sometimes you don't even recognize that they were really anonymized because just the solution works quite well. And here you can clearly see those people. They don't have the weird eyebrows and the weird features in their skin. They look perfectly normal. Just with the anonymization, they get slightly adapted and changed. Okay. So the last thing I want to show you very quickly is basically that you can now continue with the process after you have anonymized the video data, because you're not going to anonymize data just for the sake of it, right? If you can provide a secure environment where you store them, and a truly secure environment, that it may be a gray zone, but you can consider not anonymizing data. But once you want to process the data, do something with it, maybe forward it to other parties that need to work on the data, like in the example of autonomous driving, most likely a company will not do all labeling by themselves, for example. So they will basically forward it to third parties. The third parties, they will forward it to contractors. Maybe the contractors will even forward it further. But in the end, the company that were creating the data and filming the data, they are liable for the privacy of all those people that were filmed and all those license plates. So that's maybe one of the scenarios where you say, okay, it really makes sense, and I really have to ensure that I anonymize this entire data in order to be compliant with GDPR. So because there's just a risk that some of the data, gets lost or goes into the hands of the wrong people, or accidentally gets published or so, and that can actually cause major lawsuits that are very sensitive, also from a cost perspective, and obviously you want to avoid that. So we just install, and that's just mocked up, so you can just see, for example, if you were to use this with our DXC robotic drive platform, we could basically build the process environment where you have the data and then can send it to one of the tools on the platform. For example, you say you have now anonymized video data, 20-minute video or so, that you want to send to our analyzer. You can do that, and then the analyzer will basically find scenarios where it's raining, or the developer needs to find scenarios where it's raining, or where a car is driving towards a red light or a left turn or anything like that. On the other hand, you can also send it to our labeling service. They will basically then basically send the data to, for example, a third party that our client has in space to do the labeling or so. And then that's where it makes a lot of sense to have anonymized data, just because you want to be very sure about you're being compliant with GDPR, and really following your social responsibility to all these people and individuals that you're filming, and that their privacy information you're basically using for your own research. And I mean, depending again on the use case that anyone would want to follow, this is very customizable, and it's really individual to that specific use case. So the final message I want to give everyone is basically that this solution can be implemented into any kind of process landscape, or any kind of architectural environment that might be available already. And that's basically what we want to jointly do moving forward. Okay, so now passing it over, I'll stop sharing, passing it over to Marian, so you can continue with some of the cool facts about Brighter AI and what you have accomplished in the past already.
Yeah, thank you so much, and thank you for the demo. It's always nice to see the own product also in a different environment, and actually being like seeing it so streamlined in a demo. good things that happened during the project. And in a nutshell, talking again about the deep natural anonymization and what it's about, and also maybe there are some question marks like why naturally anonymizing, for example, license plates and faces. What is it all about? So as Philip already said, it's about making the data compliant, but even more having them in a way that you really can use them afterwards for your training and data sets. So our mission in a way is to keep the data as raw as possible. This is, for example, why we're also replacing the license plate with natural other license plates. If you ask a data scientist, they always want the data to be as close as the ground truth as possible. Well, actually, they want to have the ground truth. So our objective is to replace those identifiables, that the data afterwards is fully usable, and that actually our clients, or with the robotic drive, the clients can take off privacy out of their mind and can just focus on their objectives, and don't need to think about is this now a license plate from a region that we need to look at? Can we now share it with a different partner? What is the data processing agreement around this data set? So really focus on the core objectives, and afterwards don't have blurred faces or have blurred license plate that might influence data modeling, data training, or the labeling. And we actually ensured this for multiple of our clients. So we're working from Intel to Renault to also Valeo together. And this is what I'm showing here on the slide was a quite cool project as well with Valeo, where they actually published a data set online. So they collected the data all over Europe and actually also within China. And everyone who's been in the process of actually collecting data in China knows that it's quite challenging to also get this data to Europe due to data protection regulations within China, in fact. And so this data set was collected and was needed to do certain tasks for autonomous driving, like vehicle detection, landmark detection, path prediction, understanding the behavior of the individuals. And one thing was quite certain from the beginning, that this data set will not be worth anything for sharing or for sharing publicly, or also for internally for Valeo, if the data cannot be fully used. So as you see here, it's a fisheye data. On the left side, you see the original. Below that, you see the artificial replacement. And in the middle, you actually see how the data set can be used afterwards between or comparing the original versus the anonymized with deep natural anonymization. And we're hitting there the exact same scores. And also we collected here a couple of, it's basically for the PSNet on the Woodscape data set, and for different classes to be detected, like vehicles, landmarks, and person. We also ensured that even, for example, a person where we altered the face with a synthetic one, there's really no difference. And those kind of results you cannot see with traditional anonymizations. You always have variations. And if there's a space where you want to get to 100%, then it's an automotive, and it's an mission critical data, such as data for autonomous vehicles. So really maintaining the entire value while companies can just focus on their work. This is why we also make it extremely easy to integrate our solution. There's a API that we basically host for clients that don't have own server capacities, or an on-premise version which can be deployed, in fact, within minutes as a Docker container, start and run it for first testing on the own data center of our clients. It works on a variety of data sets, so all the classical automotive cases are covered, and I will actually show some other use cases in other industries in a bit. And it's designed with privacy by design. Auditors have checked it with approval that it can be used in regards to GDPR, have been used also for other companies in relation to the CCPA, so the California Consumer Privacy Act. So really also in terms of privacy, a state-of-the-art technology to use. And looking at some other cases, which we found very interesting and would like to share, we and Facebook AI research together with about 12 universities, including Carnegie Mellon and KAUST, we did a project together where the data was needed for egocentric vision, essentially the development of the next Google glasses whenever they will come, but head-mounted cameras in sports, in the private space, they become more and more famous. And this data that is being collected by those head-mounted cameras is quite interesting to actually analyze the environment, analyze the doing of the people, understanding the everyday life or understanding certain tasks. But of course, this is mass amounts of data. It's companies that have a promise towards privacy, and you obviously have quite a lot of personal identifiable information on those images. So this was also a success case. Look it up on our webpage, and you can read into the case study where actually this data was processed by the universities through our solution, and then afterwards being able to be shared around the world. Another interesting case, and Philip already actually showed it early on in the demo, is medical data. And this was also quite surprising for us, but the moment we started working on it, it became quite obvious. In the medical space, for example, Stryker, they're working with videos and image data from surgery rooms to actually use this data for training purposes, as well as for dedicated training to understand how the people behave in the surgery room. And one thing which was crucial for them is that the entire staff, including the patients, are 100% protected, and that they can basically ensure that privacy violation is completely blocked. But on the other hand, what you have in those surgery rooms is effectively only faces and gaze. So where does the person look at? How does he interact with the environment? And those are the interesting parts, which means if you would blur in this kind of scenario the face and just put a black bar or blurring on top, you lose basically the entire value of the data. And so those are kind of like three cases from automotive to egocentric data, which or egocentric vision, which I believe is going to be quite huge, and also healthcare, where this technology empowers companies to really drive their data-driven use cases and work with data, but can put the privacy more into other hands. And such as for DXC and the robotic drive, I think this is also a next step of bringing our technology together actually with an ecosystem that is way beyond what we initially thought when we started this company.
Great. So I think thank you, Marian, also for sharing these great examples, even some client references. I think that's actually quite unique for well, not unique, but it's rare that startups have such fantastic and outstanding client relationships that they're able to share the names of some of the projects that they have done in the past. Sure was part of the reason why we were specifically interested in Brighter AI, by that reputation. And I think we're closing the content part that we wanted to share of this session right now, and we would like to open up for questions that you might have. And I have already seen that there's a question by, I think, a colleague of mine in the chat. So maybe we go ahead and start with that one.
So if I may, I can read out loud the questions, maybe going from the Q&A box. Someone is wondering whether the platform is agnostic with all the systems, and how does the integration work like? Will it be plug and play or custom built?
So when I assume when the person says the platform, is the person talking about robotic drive, that platform? So I mean, generally, yes, that's actually the approach that DXC is taking, that we're a technology agnostic company. So we have a little bit of IP in that platform as a setup itself, but how we in a modular way put it together, and which components we need to cover a certain case at a client side that is very much agnostic. And also when we're thinking about the solution that Brighter AI contributes, we're extremely flexible in how to implement or how to host it. Marian, maybe you can share a little bit about just again about how you're basically able to cover any need that is out there.
Yeah, it's actually good that you answered it before. From now on, we will only sell through DXC, so only your integration matters. No, but in fact, we the standard solution, as I said, via API and Docker container can be run within minutes. It's actually quite easy and quite simple and fast. The more a solution or basically a client has specific needs, we can also customize the solution to adjust it to a specific use case. But that usually comes also with massive amounts of data, where it then really makes sense to fine-tune parameters, to fine-tune thresholds to get the optimum output for our specific client, if this answers the question.
Mm-hmm. Perfect. Then maybe we move on, because we have a few more questions and we want to cover them all. So next question in the Q&A box is the technology compliant with other countries' data regulations? For instance, in California or in China, how is your system devised so far?
Yeah, so basically, a legal advice early days said, if you make it in Europe, if you make it with the GDPR, you're safe around the world, and it's very much the truth. The GDPR is one of the strictest regulation in terms of privacy, and basically the CCPA we cover with that, and also the CSL in China, the JAPP from Japan. So it's basically a soup of letters of regulations around the world. And so far, with every client, we could set up the system that they can use it compliant.
And I think just to complement that, I think to have the data itself compliant according to the regulations is extremely important. And then I think what's interesting for the client is, again, that the offering that both of us are providing to basically design the entire data governance, that how you're dealing with the data and how you're treating that. Again, that's part of DXC's core capabilities of implementing processes, implementing ways that the entire environment is basically designed in a compliant way in any
Perfect.
country, to correspond right to that question.
Mm-hmm. Moving back maybe to the chat, where we have one question from one of your colleagues, Philip. I think he's wondering if you, Marian and Brighter AI, if you guarantee or commit to a 99% anonymization, or is this a best efforts base, or do you typically agree on strict SLA according to the client industry or the client needs? How does it work usually when you approach clients?
Yeah, so it's both. We, for the data that we test and that we train on, and basically the use cases that we target, we achieve a 99% score of basically readable and recognizable faces and license plate. So the ones that you really can recognize and read. And in the end, data that we haven't processed and that we haven't seen, we cannot give a number on. So what we usually do for bigger clients, we do an assessment at the beginning and then do, as I said before, for example, fine-tuning. And then in the end, because we can show that we have in the industry the highest grade of recognition and that we have the highest grade of protecting the data, it's basically for most companies beyond best efforts. So they can show towards the legislation that they do all necessary steps to best protect the data, and this we can also guarantee.
Mm-hmm. And then we have another question. Is your software limited to faces and license plates? Because cars might carry advertising text or images that allow identification. So how are you dealing with these situations? How are you anonymizing like the whole kind of car or object, or yeah?
Yeah, so we are quite happy to have a good deep learning team, and so there is something on the roadmap that exactly targets text, for example, on vehicles, to anonymize that as well. From a legal perspective, as of right now, the biggest threat on data sets are, for example, face and license plate, because those models are widely available and streamlined to, for example, crawl data sets. The legal risk at the moment of certain text on the vehicle being from a private person. So consumer vehicles that have a text, they wouldn't count for personal data because it's a company. So the risk of someone having basically a customized sentence on his personal car is very, very low and is currently not seen as highly critical. So it's not as relevant as of today, but still we're working on next anonymization features anyhow. And happy to anyone who's interested, like if Martin, you have there a concrete request, contact Tobias and we can talk about when this feature is going to come.
Okay, then there was another question, I think maybe related to the previous one we covered. Is there a fallback mode in case the software cannot 100% anonymize the data because it doesn't recognize something or the type of data or pattern that is being used? So the question is, are you using some sort of blurring or black the pixel?
So and if basically the faces could not be found in the natural anonymization, they would also not be found in the blurring. However, from all the tests and from everything that we see from the major data sets and clients that we work with, we're actually recognizing effectively too many faces and too many license plates. So we have our threshold to find faces and license plates is so high that we exclude specific ones, the ones that are not recognizable. So the possibility that we lose a face and not recognizes is quite low. And if we see this is happening, it's usually on faces and license plate that you cannot recognize anyhow. So the chances for a face and license plate that you recognize as a person, I would say we're close to 99% of really also getting this face as well and anonymizing it. If not, it's probably a PII, a person identifiable, which is not really identifiable anyhow.
Understood. And then I think we have one more question. You showed examples of your system not affecting predictions for retrained models. Have you come across models or data sets where your system does have an effect?
So the more basically, for example, like in the cases of driver monitoring, we've did studies there where you have a closed up face and the exact mimic points are needed. We don't get to basically the exact same numbers, but those cases, so we're still above 95%. And for those cases where it's about drowsiness, for example, or aggression levels in public, the numbers and the results we reach are still sufficient enough for those use cases. In basically the automotive space, as well as medical or in the space of public transport, on the data we don't see any changes. It becomes more tricky, and this is something that we usually test at the very beginning with the companies, when it's like high closed up faces, which you usually don't see in the industrial space.
Thank you very much. And maybe going back to your partnership with DXC, because I don't think we've touched upon what the future holds. So I was wondering maybe in the last couple of minutes, if you could tell us more a bit what the future holds for your collaboration, for your partnership. What do you want to do next? How do you see this collaboration evolving maybe?
So I think the Startup Autobahn program was basically the platform to meet, and now we want to take it forward from here. So this is basically the starting point. We have began by developing this demo that now we want to position in the market and actively approach clients that we want to help with in basically designing data environments that are in a way how we just described it. We have also already written a white paper on GDPR-compliant data processing that is going to be published sometime. I think I would hope next month that we actually publish it to basically show that to the industry what's coming up next. So look out for that. And yeah, as a matter of fact, we do have projects in mind that we can talk about now, obviously, but that we want to approach together and actually get into the first commercial agreements together.
That sounds great. Then we all have to just click follow on DXC Technology and Brighter AI on LinkedIn to keep us up to date with what you guys are planning to do up next and what other industries maybe you will be touching apart from the autonomous driving one. I guess thank you very much, everyone, for tuning in, and thank you very much to the speakers for the demo and for the questions that you answered live. If someone has more questions, you can get in touch with the speakers via the agenda on our website. You can see their profiles there, and some of their contact details are added. So that's easy, the easiest way, I would say, to get in touch with them. So thank you so much, everyone. I hope this was insightful, and we're looking forward to see what new things you will come up with.
Great. Thank you very much, and have a good day.
It was a lot of fun. Thank you, Theodora.
Thank you so much.
Everyone.